So guys, today we are going to discuss about Hadoop. It would be not a soft introduction, but yeah, it would be like an introductory session on Hadoop. Let's firstly see the agenda for the day. So guys, the agenda is introduction to Hadoop, why Hadoop, basic architecture of Hadoop. So guys, in the basic architecture of Hadoop, we are going to see that how exactly Hadoop systems look like, how exactly Hadoop is deployed, or how exactly the cluster will look like. Then we will discuss introduction to HDFS. The very first component of Hadoop is HDFS. Then we will discuss introduction to MapReduce. MapReduce, as discussed yesterday as well, MapReduce is the heart of Hadoop. Then we will see Hadoop Daemons, complete end-to-end flow of Hadoop, how Hadoop works, its characteristics, then different flavors of Hadoop. Okay. After that, guys, we'll see Hadoop ecosystem. Hadoop is not a single component. There are a number of different components are with the Hadoop. We are going to discuss all those components also. Okay, let's start our session. Let's start our session with introduction of Hadoop. What is Hadoop? Hadoop is an open source project. Guys, Hadoop is an open source. That is really a beautiful thing, that its source code is open. Open source means its source code is open and it's a freeware. Hadoop is an open source project from Apache Software Foundation. What do I mean by open source? Its source code is open. Now you will ask me, will enterprise accept open source solutions? I would say Hadoop is the first open source solution that has been accepted by all the industry, by all the domains. Even Microsoft has done the partnership with Yahoo to make Hadoop compatible with Windows. Now you'll ask me, if some organization don't want open source, I would say, guys, Hadoop is coming in proprietary version also. In the later section, we will discuss that different flavors of Hadoop. There we will see that, okay, which are the proprietary version, commercial versions of Hadoop that is also available. But let me tell you guys one beauty behind open source. So it's almost 1 year old story. When we were working with a retail client and certain functionality of Hadoop was not fulfilling our requirement, it was not able to solve our problem. What we did, we simply downloaded the source code, changed it according to our requirement, and we deployed it back. That's it. That's the beauty of open source solution. By the way, guys, I am also part of this Apache open source community. I have also contributed few modules in Hadoop. Hadoop provides a software framework. Hadoop provides a software framework for distributing and running applications on cluster of servers. Guys, the very first thing, Hadoop work on clusters. Hadoop works on cluster of servers. Can anyone tell me what is a cluster? What is a cluster? Correct. Group of machines. Correct. Multiple machines connected together. Correct. Perfect. Correct. Group of systems. Correct. Collection of nodes. Yes, I think all the rest of the answers are pretty much similar. So guys, Hadoop doesn't work on single machine. Instead of that, Hadoop works on hundreds or even thousands of machines at a time. Now guys, by the way, just from this slide only, I'm starting discussing on the architecture of Hadoop, some design principles. So guys, if you recall our yesterday's session, when we discussed about the problems with the conventional approaches, just relate, just try to recall those problems, and just from the design principle of Hadoop, all the problems are resolved. Today when we'll see the exact working end-to-end working of Hadoop, you'll say it's really an out-of-the-box solution. It's really something that is developed from scratch of wow, totally different technology. So guys, the very first thing is it works on cluster of servers. Second point, it provides software framework. For distributing and running applications. Your application will be distributed and run on cluster. So guys, Hadoop is inspired by Google's MapReduce programming model and its file system. We all are aware that Google is the mother of all the innovation. Google is mother of all the invention. So when Duck Cutting and his team was working on Nut search engine at Apache, they got a requirement of a distributed storage and processing framework, which is pretty much similar to what Google has written a paper. So in this manner, the development of Hadoop has started as sub-project. Hadoop was merely a small sub-project of Nut search engine. But guys, very soon due to the popularity and power of Hadoop, Hadoop became top level project. Do you know even when Hadoop was even not launched, even what it was not in beta, even it was not in alpha, at that time Hadoop has defeated supercomputer. I'm talking about 2008 story. Hadoop has defeated supercomputer in Terasort. There are a number of different benchmarks has been set at that time. That's why the development of Hadoop started at full pace. And guys, another interesting thing is that Hadoop's code, this open source code, came mainly from Yahoo, Facebook, IBM, Cloudera, the top-notch talent of the industry. They have committed this particular code, and that's why Hadoop, the solution of big data, is a very big solution, and that has been accepted across the globe. Let's proceed ahead. Hadoop is an open source framework that is written in Java. Now at this time guys, you'll ask me, okay, Hadoop is written in Java, so do I need to have the knowledge of Java? Guys, from Hadoop, from the Apache, it's not mandatory. They are saying that you can code in language other than Java also, like C, C++, Perl, Python, Ruby, any language. You can code in any language other than Java as well. But guys, my personal experience that you must code in Java. Why so? Because the top level APIs won't provide you the lower level control. The top level APIs won't provide you lower level control. That's why it is recommended to code in Java, because it is developed in Java. So Hadoop efficiently process large volumes of data. Guys, processing of large volume of data is very efficient, very fast on Hadoop, on cluster of commodity hardware. Now, can anyone tell me what is a commodity hardware? What is a commodity hardware? Correct. Low-end machines. Correct. Cheap hardware. Correct. Like our i5 machines. Correct. Less expensive machines. Correct. So guys, Hadoop is deployed. Hadoop can be deployed. Even let me give you a correct figure. From Yahoo, actually I was discussing the same with the vice president of Yahoo. Yahoo has deployed, by the way, this is almost a 9-month-old story. Yahoo has deployed 54,000 machines, 54,000 commodity machines for Hadoop. 54,000 machines were running 9 months ago. Now it would be quite big. Now you'll ask me which company is having biggest cluster of Hadoop. I would say it's Facebook. Number is still not revealed. Okay. Now the point here you should understand, guys, Hadoop is pretty much economic. It doesn't require any specialized hardware. If you compare it with any other technology, whether that is Oracle, whether that is DB2, whether if you talk about mainframe, the hardware costs are very high. It's very high. On the other hand, Hadoop can be deployed on merely commodity hardware. So guys, another reason of behind the popularity of Hadoop, because from the startup, from the small scale out to the large scale, everyone started working on this due to its economic factor. Now guys, till now I was saying that Hadoop is deployed on cluster. There are hundreds or thousands of machines working together so that my system would be pretty fast. I again and again told, but Hadoop can be set up on single machine also. Hadoop can be set up on single machine. Now if I want to learn Hadoop, I'll not purchase 100 machines. For learning, for research, for development, for your R&D, for any other purpose, for your testing, you can set up Hadoop on single machine as well. But real power of Hadoop comes with a cluster of machines. Real power of Hadoop comes with cluster of machines. And another beauty, it can be scaled. Hadoop can be scaled from single machines to thousands of nodes on the fly. Thousands of nodes on the fly, guys, without any downtime. This on the fly point you should note down. By the way, I am hoping that guys, all of you are having paper and pen ready with you. So the new terminologies that we are discussing, you should note down, because these are pretty new even in the industry as well. So there are very less, I would say, or if we check the systems that are available, just 0.01% systems are available who can scale on the fly, that is without any downtime. That's really very important, because guys, in today's era nobody really accepts downtime. If you'll ask your business users, if you ask your client that, boss, I want 1 day's downtime, I want to scale my system, I want 5 hours downtime, it's really very annoying. Nobody really accepts in the industry downtime. On the other hand, if you are working on legacy systems, you don't have other options. Okay, let's move ahead. Hadoop consists of 2 key parts. Now guys, this 2 parts you should note down. The very first part is Hadoop Distributed File System. Hadoop Distributed File System, or HDFS. Guys, HDFS is the storage layer of Hadoop. HDFS is the storage layer of Hadoop. By the way guys, just 3 months ago, HDFS has been accepted as world's most stable, world's most reliable storage layer. World's most reliable storage layer. And second part is MapReduce. MapReduce, the heart of Hadoop. MapReduce, the heart of Hadoop. Hadoop is that much popular due to MapReduce. We will discuss all these components in great details, but before that, let's talk about another important point. Why Hadoop? Whenever you learn any new technology, always you should ask why I should learn this, or why I should switch to this technology, or why if I'm deploying, if I'm answering, why I should use this, I should deploy, I should solve my problem using Hadoop. The very first point, Apache Hadoop is a platform for data storage. Guys, Hadoop provides you both the features. First feature, that is storage, and second is processing. Hadoop provides you both the features. First is storage and second is processing. That is scalable. Okay, let me give you one fact. Say for example, if you deploy your warehouse, on Oracle, if you deploy your warehouse on the top of Oracle, guys, your warehouse is not really scalable. That is, say in 2009 you deployed it, and you were expecting that in 2014 you will be having around 1 million users, and it will really can really handle that much data that you are going to get. But due to unprecedented growth of your business, instead of 1 million you are having 20 million users. Now you'll be very happy that my business is growing very fastly, But another issue, your warehouse can't really scale. Your warehouse can't really scale if it is Oracle. But if it is Hadoop, it can be scaled to, if I give you guys one figure, what I gave to TTSL, Tata Teleservices. I am providing you a solution that is infinitely scalable. What do I mean by infinitely scalable? Guys, as more as you want, as long as you want, you can keep adding more machines. Say for example, today you are having 50 node cluster and your requirement is increasing. Number of users are increasing, just simply add 10 more machines. Okay, now you are having 16 node cluster. Now 16 node cluster, yeah, it will surely fulfill your request. Tomorrow it's double than what you were expecting of your business growth. Your business growth is double. No issues. Simply double the cluster size, 60 to 120. As soon as your data requirement is increasing, as soon as your processing requirement is increasing, you can keep adding more machines. And another beautiful fact here is that, guys, you can even add just one machine also. There are few systems, few big data solutions also available that won't allow you to add one machine. There are certain minimum requirement that you must add these many machines. But in Hadoop, you can add from 1 to thousands of machines at any point of time without any downtime. Okay, Mohit is saying it's really very excellent feature. Yes, Mohit, it is really excellent. So if you have worked on any of other warehousing tools, it is one of the major pain point. But Hadoop has resolved that pain point. Let's proceed ahead. Second feature, that is fault tolerant. Second feature is fault tolerant. Now, since Hadoop works on cluster, that is, suppose I am having a 100 node cluster. Now guys, this fault tolerant feature, with this fault tolerant feature, if few machine fails, out of 100 nodes, suppose 2 machines are down, 2 machine failed, there are power failure, there are some extreme issue, just machine completely failed, then also your system will be up and running. Hadoop is having the capability of self-healing. That is, failure of machines won't affect the data storage as well as processing. If machines are failing, then also your system will be up and running. You will respond to your client's request. You will respond to your client request about processing as well as storage of data. Again, very important feature. Another feature, what we already discussed, open source. Being open source solution, you are open to change the source code. It also saves you from the vendor lock. You can change the vendor at any point of time if you don't like their services. Okay, before going to other features, let's talk about these two core components of Hadoop. HDFS, Hadoop Distributed File System. As discussed, this is the world's most trusted storage system. World's most trusted storage system. Guys, distributed, it provides us the capability of distributed storage and data protection across physical servers. Data protection across physical servers. So if your machines are going down, then also your data will be saved. Your data will be saved. So I'm getting one question. Just wait for 10 more minutes, Ankita. Your question will be answered when we see the architecture of Hadoop at that time, how Hadoop is pretty much better. The second component is MapReduce. Although guys, there are dedicated slides for HDFS and MapReduce also. We will discuss that as well. MapReduce, that is the processing layer of Hadoop that provides you distributed computing across parallel servers. Now, Hadoop has the flexibility to store and mine any type of data. Guys, recall our yesterday's session. Hadoop or RDBMS can only handle structured data. But Hadoop can mine or store any type of data. You can ask any questions. You can ask questions across structured, semi-structured and unstructured data that were previously impossible to ask. Hadoop is not bounded by a single schema. Hadoop is not bounded by a single schema. You can store any type of data, guys. You will be surprised to see the storage system of Hadoop. You can merely create a directory and you can store your data as it is. You can store your data as it is, whether that is a say multimedia file, whether that is a normal text file, whether that is a structured data, whether that is a XML data. Any type of data it can easily handle. Okay, let me take one question. It's pretty relevant. Does Hadoop provides the capacity analysis of cluster so that we can get to know when to increase or decrease nodes from the cluster? Yes, Karanjit, it provides the complete analysis. There are several commands using which you can get it, or there are a nice web UI also available. Using the same you can get it. Everything is available. It is a quite commercial or enterprise software now, and that is providing you complete end-to-end information about your complete cluster. Hadoop excels at processing complex data. Hadoop excels at processing complex data. Guys, it's scale out architecture. Hadoop's scale out architecture divides the workload. Its scale out architecture divides the workload across multiple nodes. Like, instead of one machine working, like recall Oracle, just one machine was working. That's why there was issue of limited processing capacity. On the other hand, in Hadoop there are hundreds or even thousands of machines working at any point of time. That's why it's pretty much scalable, flexible file system that eliminates ETL bottleneck. Guys, recall our yesterday's session. In RDMMS, it always require ETL, extract, transform and load, but HDFS doesn't require ETL. You can directly extract the data and load as it is. You can load raw data as it is. As suggested by data scientists, you can store raw data as it is inside HDFS and you can transform if required to any format. Okay, another important feature what we discussed, it scales economically. It can be deployed on commodity hardware. Companies like Yahoo have deployed Hadoop on commodity hardware. Open source platform guards against vendor lock. You can change even your vendor at any point of time if you don't like their services. Okay, just guys, here I have highlighted few features of Hadoop that are really amazing, that are really pretty new, pretty important, that were not available in your legacy systems. Now, after looking at the answer of why Hadoop, let's see the very basic architecture of Hadoop. I'm saying basic architecture because we are just looking from quite high, I should say. And with time we will drill down and see a lot many information about the architecture. We'll drill down and see more information about the same. The very first observation, Hadoop works in master and slaves fashion. Hadoop works in master-slave fashion. You can see guys, there are few masters and there can be hundreds or even thousands of slaves. There can be hundreds to thousands of slaves. Now guys, if you recall Oracle, if you recall Oracle system, what was there in Oracle? If client submit any query, I am having just one system. Suppose your DW is on the top of Oracle. I am having just one system, and on that system it is performing complete processing of data and it will return you the results. On the other hand, I'm comparing it with single system setups, single system warehouses. On the other hand, here in Hadoop, if user submit any work, your master will submit the same work to all the slaves. Like Suppose I am having a 100 node cluster. If I am having a 100 node cluster, 100th work will be done by this machine, 100th work will be done by next machine, 100th work will be done by all the machines. Automatically my system is at least 100 times faster. 100 times faster. So guys, your work will be submitted by master to all the slaves, in the cluster. The first major difference. Okay, let me take one question. HDFS is a file system. RDBMS uses to access data SQL. How does data access of HDFS? Okay, there are multiple ways to access data from HDFS. To access unstructured data, you surely need to run the commands, or you need to write a program. You need to interact via the Java code to access any data from the HDFS. On the other hand, if you are having data that is structured, again you can use SQL. Hadoop also supports SQL using one component that is called Hive. We will discuss Hive also in great details, just a later point of time. So guys, I think just by this point of time, all the issues that was with the legacy system is resolved. Just one thing is remaining, that is how Hadoop is different from other distributed system. That also we'll discuss with HDFS and MapReduce features. But if you recall, limited storage capacity, now I am not having any limited storage capacity. With each and every machine I can have TBs of disk, and overall I can store petabytes to even zettabytes of data. Petabytes to exabytes of data I can store inside Hadoop cluster. Not only store, I can process that data using MapReduce algorithms. Okay, now all the data will be stored distributedly. Another important point is that when users submit any data, the data will also be stored distributedly. Let's see that how exactly your data is stored distributedly using HDFS. Okay, before that, let's understand what is HDFS. Guys, HDFS is a distributed file system. HDFS is a distributed file system. If I highlight few points, it's a distributed file system that is designed to run. Now guys, from its design only, it was taken care that it can run pretty much on commodity hardware. Commodity hardware means low cost machine. Commodity hardware, it means low cost machines, and where the chances of failure is pretty high. Hadoop can be deployed on such machines also. Hadoop file system, that is HDFS, is highly fault tolerant. It's highly fault tolerant, distributed, reliable. Now guys, I'm highlighting these points. If you want, you can note down this, because tomorrow we'll discuss all these points in great details. Tomorrow's session is dedicated to HDFS. So guys, it's highly fault tolerant. Fault tolerant means failure of any machine won't affect your cluster. Say out of 100 machine, if say few machines are down, then also your system is up and running. Distributed. What do I mean by distributed? Your data is stored distributedly across all the machines. It's reliable. Your data is always stored reliably. And it's scalable. HDFS is pretty much scalable. Okay, another important point, it provides high throughput access to application data. It provides high throughput access to application data and is suitable for applications that have large data sets. Now guys, Hadoop, since it is distributed, it provides pretty high throughput. Its throughput is very high because I will get the data, will get this data to the application from multiple disks, multiple systems. Apart from that, it is suitable for large data set. If you are having data in the range of few MBs or just few GBs, Hadoop is not recommended. You should not go with Hadoop. if your data volume is high, then only you should use Hadoop. Hadoop is developed to handle huge volumes of data on a cluster. So let me highlight just huge volume here. That is large file size, that is in the range of GBs to even TBs. We will see how exactly it stores the data. That is again a quite nice concept. A file is split up into blocks. How Hadoop stores the data? A file is split up into blocks. Your file is split up into blocks. The default block size is 64 MB. Now guys, can anyone tell me the block size of normal file system? That is your NTFS, FAT32, ext4. What is the block size of your normal file system? Correct, 4 KB. It's the default one is 4 KB, or you can even increase to 8 KB also. But look at the block size of Hadoop. It's 64 MB. Pretty huge. It means, you can note down one point guys, it means HDFS is not a general purpose file system. HDFS is developed to work on huge volumes of data. It works if you are having volumes. HDFS is not a general purpose file system. By the way, can anyone tell me any general purpose distributed file system? I'm sure all of you have worked on that. General purpose distributed file system. So NFS is a distributed file system, that is a general purpose. So guys, it split up the file into blocks and stored distributedly. The blocks are stored distributedly across multiple machines. It means if you are having one file, Hadoop will break that file into multiple pieces and store across all the machines. We'll discuss this again in great details with some animation. It stores multiple copies of data. It stores multiple copies of data on different node for the purpose of fault tolerance. Okay, GFS, Google File System. Yes, it is also distributed, but that is not a general purpose file system. HDFS is developed from the idea it has taken from GFS only. That is Google File System. No, FAT32 is not a distributed file system. Now let's understand the storage mechanism of HDFS. Guys, it's very important to understand this. I am trying to help explain this with the animation. Now on the right hand side you can see the Hadoop cluster that we have already seen, where we have masters as well as slaves. Few masters and thousands of slaves. There can be thousands of slaves. Okay, now understand it. If I am having a large file, the file size is 100 TB. The file size is 100 terabytes. How exactly file is stored on Hadoop cluster? Understand this carefully. Now, firstly, the file is divided into small blocks. Block 1, block 2, block 3, block 4 and so on. The block size, guys, if you recall, 64 MB. So there will be thousands of blocks. This file will be divided into thousands of blocks, and these blocks will be, look at this guys, look at the animation. These blocks will be stored distributedly. Like block 1 available here, block 2 available here, block 3, block 4 and so on. Guys, for this simplicity I am just showing 4 blocks, but there will be thousands of blocks for this particular file. So you can imagine the blocks are stored on all the machines distributedly. Now you'll ask me, if the user want to get the file back, Hadoop is not having the complete consolidated file, then how you can get back? Guys, corresponding to all the blocks, corresponding to your file, corresponding to all your data inside Hadoop, there will be metadata. There will be metadata that is stored on the master. Master stores the metadata. Master doesn't store actual data. Look at this. All the blocks are stored on the slaves. The blocks are stored on the slaves. But metadata, that is data about the data, is stored on the master. Now, Hadoop creates multiple copies. Guys, look at this. Hadoop creates multiple copy of all the blocks. Look at this. Block 1 is available here, as well as here, as well as here. 3 copies. By default, Hadoop creates 3 copies of each and every block. By default, Hadoop creates 3 copies of each and every block. Now, if you recall the fault tolerance feature, guys, at any point of time, suppose this machine is down, no issues. I am having data available here as well as here. My master knows, master that is having metadata. Master is having metadata. So master knows where are all the blocks are stored, where exactly all the blocks and all the replica are stored. So master will redirect the request to another slave where the data is actually available. Where the data is actually available. From that, master will redirect the request, or master will get the data from there. Okay, let me take one relevant question. Since data is stored distributedly, how does HDFS take care of disk corruption? Does it have any checksum? Yes, there will be checksums also stored with that data. So in case of any disk failure, that data will be discarded, or even suppose disk failed and that data is not even available. Even I am showing you the complete extreme case. The machine is down. Not even few files are missing, not even your disk is crashed, not even few data is corrupted, few block is corrupted. I'm saying complete block, complete machine is failed. There is power, the machine is, there is power issue in that machine. Machine is now switched off. Then also there will be no issue. HDFS is pretty intelligent. It will take care of, it is self-healing. It will take care, and your master will automatically remove this machine from the cluster, and it will send the request, it will forward the request on the other nodes where blocks are available, where the blocks are available. Okay, a good question. What if the master is down? No issues. If you can see, I am having multiple masters available with me. You can see multiple masters are there. Apart from that, guys, we are having the backup master also available. Like suppose with this, I am having master 1 dot dash. That is, if master 1 goes down, 1 dot dash, 1 dash will automatically become the master. So that is also highly available. Masters are also highly available, so there is no issue of any downtime. There is no issue of means even the cluster that are running, that will keep running forever without any issue of making if any systems are down. A brief introduction, a brief discussion about HDFS, guys. We have seen. We'll discuss HDFS in great details tomorrow. Tomorrow the session is dedicated just for HDFS. Let's proceed ahead today for the next component, that is map reduce. Let's see map reduce. What is map reduce? What is, okay, before proceeding ahead, let me take one question. What type of machine is master? Good question, but tomorrow we'll discuss the same thing in great details. Usually master machines shouldn't be commodity machine. Master machine should be highly available machine. Master machine should be of better configuration. Okay. All right. Map reduce. What is map reduce? Guys, again let me repeat the things what I told you previously. Map reduce is the heart of Hadoop. Hadoop is that much popular due to map reduce. Okay, map reduce is a programming model. Map reduce is a programming model that is designed for processing large volumes of data. It is designed for processing large volumes of data in parallel by dividing the work into set of independent tasks. A small definition which covers all the aspects of MapReduce. Guys, understand this. It is designed for processing. Firstly, MapReduce is the processing layer. Processing of large volumes of data. Guys, the data volume should be high if you want to use MapReduce. Surely it will work on the small data, but it is more efficient for the large data. Your processing will be done in parallel. It is a distributed computing framework. Your data processing will run parallel over distributedly across multiple machines. It divides the work into set of independent tasks. Your work will be divided and done by independent systems. Your work will be done as independent tasks. Like if you recall, guys, our cluster, so multiple machines independently work and solve your problem. Okay, we'll see this again with an animation also. Before that, let's see another definition. So guys, MapReduce is the heart of Hadoop. MapReduce is the heart of Hadoop. It moves computation close to the data. Now guys, it's a very important point. You can note down this point with 5-star marks line. 5-star marks. It moves computation close to the data. Hadoop doesn't move data. Instead of that, Hadoop moves computation close to the data. Guys, recall our yesterday's distributed systems. There, if you recall SAN, there was a requirement of data movement, but with Hadoop there is no requirement of data movement. Instead of data, here computation will be moved. Computation will be moved to the data. How it is moved, we'll see again with an animation. This programming paradigm allows for massive scalability. This allows for massive scalability across hundreds or thousands of servers. In a Hadoop cluster, there can be thousands of servers. There can be a very big cluster in the Hadoop, and your data will be processed pretty much scalably over the complete system. Let's understand the same via the animation. Okay, so guys, if you recall previously we had a Hadoop cluster. There we already stored the data. Data is splitted and stored across multiple machines, like block 1 here, block 2 here, block 3 here, and so on. Now the next point is that user want to process that data. Now understand this is really important. User want to process the data. User will tell that, boss, I have already given you the data. User will come to the master and tell that, boss, I have already given you the data. Suppose user has given a file called employee data.txt. User has already given that data. Now user need to develop a code. User need to develop an algorithm, that is MapReduce job. User will develop MapReduce job. User will develop MapReduce application, and he will submit the same application to the master. He will submit this algorithm to the master. Okay, now master will check. Since master is having metadata, since master is having metadata, master will check where are all the blocks stored for this file. Where are all the blocks stored for the file that user want to process, like employee data.txt. Okay, master will come to know, okay, block 1 is available here, block 2 here, block 3 here, block 4 here, and so on. So master will send the same algorithm. Guys, look at this. Master will send the same algorithm to all the slaves wherever the data is available. Wherever the data is available. That is, master moved the algorithm. Master moved the computation to the data. Instead of moving the data, I am talking the data that is in the range of petabytes, exabytes. Is movement of exabytes of data feasible? No. As discussed yesterday as well, movement of data is prohibited in data industry, in today's data industry. That's why, guys, Hadoop has come up with another principle that is called data locality. You can note down the name, data locality. So guys, with the data locality, Hadoop moves algorithm to the data. That is, algorithm size would be hardly few kbs, just 10 kb, 100 kb, hardly 1 MB. That's an extreme case. So just these few kbs of data will go here, and this algorithm will run on this slave. This algorithm will run on this slave. This copy of algorithm will run here, and it will process the data that is available on this slave. That it will process the data that is available on just this slave. Algorithm's copy will go here, and it will process the data that is available on this slave. So guys, parallelly your algorithm will go on all the machines wherever the data is available, and it will process the data available on that machine. It saves the data movement, and it allows the processing of data pretty much distributedly, pretty much parallelly. That's the beauty of Hadoop. That is the main feature of Hadoop that really doesn't available in other systems, other distributed systems also. And another important point, guys, at any point of time, suppose this machine is down, this machine fails, or this particular process fails, that is processing block 1, no issues. Master will reschedule that work. Master will reschedule that work on another slave. Suppose block 1 is available here as well. So master will ask this slave to process block 1. So just to give you an analogy, guys, if you recall, divide and conquer algorithm. Not exactly, MapReduce is not exactly similar to that, but yeah, just for an analogy, you can understand MapReduce as similar, little bit similar to divide and conquer. Like your data is divided and it is processed distributedly, and then finally result is conquered. That is the MapReduce. Again, guys, today we have discussed MapReduce in just 10 minutes. We are in actual later point of time in the sessions, guys. We are going to discuss this almost 15 hours, as this is the most important section. Let's move ahead. Let's talk about now how Hadoop works end to end. Let's summarize the complete steps. Step 1. Input data is broken into blocks. Input data is broken into blocks. The default size is 64 MB. You can increase default size. You can increase default size to 128 MB also, or even you can increase it to 256 MB also, or 2x, I should say. 64 into 2x, that is 64, 128, 256, 512, so on. And then, so guys, input data is broken down into blocks of 64 MB, and then blocks are moved to different nodes. Blocks are moved to different nodes. So if I highlight this point, if you are noting down, data broken into blocks and then moved to different nodes. Let me highlight different nodes. Okay. Next point, next step, once all the blocks are stored on data nodes, user can process the data. Once the data is stored, user can process the data. Now, how exactly you can process the data? User can schedule the program on the individual nodes, the same way that we have discussed. User schedule the program, or your Hadoop schedules the program on individual nodes. Once all the nodes process the data, output is written back on HDFS. You'll get your final output available on HDFS. That's complete end-to-end working of Hadoop. That is, we have included both the parts, that is HDFS as well as map reduce part. Okay, let's discuss its daemon architecture, its basic daemon architecture. I recommend, guys, you can note down the same. So guys, these are the main daemons. By the way, can anyone tell me what are the daemons? What is exactly is the daemon? Correct. A background process. Correct. Process running in the background. Correct. The process that will continuously run and support to other process. Correct. So guys, a background process that continuously run is called a daemon. So guys, when you install Hadoop, when you configure, when you set up Hadoop, there are all these daemons that will be continuously running on your machines, on your nodes. Okay, let's understand this. Firstly, let's understand the storage layer. The lower layer, that is the storage layer. Again, guys, you can recall we are having few machines that are designated as master and few are slaves. Surely, slaves are pretty higher than masters. So usually we have few masters, like 3-4 masters and thousands of slaves. Okay. On master, we have a daemon called name node. On master, name node runs. On all the masters, name node daemon runs. On the other hand, on all these slaves, guys, look at this, on all these slaves, a daemon called data node run. A daemon called data node run on all these slaves. That is your lower layer. It is called as lower layer, as well as HDFS layer, as well as storage layer. So guys, in the lower layer we have mainly two components, two daemons. One is name node and another is data node. Later point of time we'll see some other supporting daemons also, but quite late. But these are the main daemons. Now, for the upper layer, that is the computation layer. The upper layer is also called as computation layer or processing layer. In the processing layer, we have a daemon called resource manager. A resource manager daemon that runs on the master. Resource manager runs on the master node. Resource manager runs on the master node, runs for the computation. Node manager. Node manager, this daemon run on all the slave. Node manager runs on all the slaves. So guys, you can easily identify name node and resource managers are your master daemons. On the other hand, data node and node managers are your slave daemons. So guys, before proceeding ahead, actually I have taken quite long continuously without stop or continuous discussion. Before proceeding ahead, if anybody is having any questions till now what we have discussed, we can discuss. If you have any questions, any point, if you want to raise any specific topic, if you want me to repeat, else the next topic here is characteristics of Hadoop that we'll discuss. So if everything is clear, guys, if I can get a smiley so that I'll be pretty much sure that all of you guys got everything 100%. As I can't see your faces, your smileys will show me that yes, everything is correct. Okay, let me take few questions also. Why 64 MB? 64 MB is the minimum block size, that is default block size of HDFS. This is actually a moderate figure that that is finalized, that yes, 64 MB, it should be at least 64 MB, because we are having, by the way, a question, if you ask me why 64 MB, why that much big, I would say there are multiple reasons, because at any point of time, one mapper out of MapReduce, one map will process, your MapReduce job will process just one block at a time. That's just giving a brief that we'll discuss later. So that's why the higher is better. And even when we'll discuss MapReduce, when we'll discuss about the production architecture, when we'll discuss about the actual in the production, what should be your configuration, I would say rather than 64 MB, you should increase it to 256 MB. According to Hartenbach, according to Apache, they are recommending it to 128 MB. You should start with 128 MB. Okay, another question about secondary node, secondary name node. A secondary name node is now deprecated. It's not really much used in Hadoop 2. Till Hadoop 1 it was there. Till Hadoop 1 it was there, but now it is deprecated. So it's surely available but of no use. Rather than that, we are having a standby node available. That we'll see later. How we can rely on this daemon thread. Actually, your daemon, when we will deploy Hadoop, at that time your daemon will be started. You will manually check that whether that daemon is running. By the way, daemon is not a thread. Daemon is a physical process. That is a hardcore heavy process, heavyweight process. And this daemon will continuously be running. Now you'll say how we can rely. I would say at any point of time, if this process is down, don't worry, you will come to know the same thing from your master, firstly. Secondly, if they are down, then also no issues. Hadoop is self-healing. Failure of daemons, failure of even machines are also getting care by Hadoop. What is search criteria applied by MapReduce for searching the blocks? Regarding this, I would say wait for some more time, Sunil. Then we will discuss this in great details, because this is more for the MapReduce thing. So we'll discuss in MapReduce section. Okay, about the default replication factor. Okay, guys, Hadoop is having a property, a configuration that is called replication factor. That is a default replication factor. That is by default how many copies of blocks should be available on the cluster at any point of time. How many copies of blocks should be on the cluster? So the default replication factor in Hadoop is 3, which we can increase or decrease according to our requirements. In Hadoop field, what is the challenging part? In Hadoop, means it's not, I would say, much challenging, means it's not really, but yeah, I would say yes, MapReduce is little tough, little complex, but yeah, if just a few practice, if you do in right direction, you can do easily learn that also. Okay, I think I have answered all the questions. Let's proceed further. Let's talk about the characteristics of Hadoop. Let's talk about the characteristics of Hadoop. The very first characteristics, open source. We already discussed that, guys. Open source means it's free as well as its source code is open. Open source means its source code is also open. That is opening, that is really providing you, that is providing the developers, researchers, even students also, they are this open source nature is providing a golden opportunity for all of you guys to do your research. You can really do your own research and you can modify the source code. Let me give you one case, guys. A company called MapR. MapR is a provider of Hadoop. What MapR did? MapR downloaded the source code. MapR downloaded the source code and changed that. MapR changed HDFS source code, and now MapR HDFS, the HDFS of MapR. MapR is also one of the flavor of Hadoop. MapR's HDFS is 100 times faster. 100 times faster than other HDFS, that is Apache HDFS. So guys, if you want, you can even copy this source code and you can sell it on your name. You can change it and you can modify that. But for the industry, if I say, guys, this code can be modified according to the business requirement. If it doesn't fulfill your requirement, then you can edit. You can edit the source code and you can change it according to your requirements. Okay, let me take a few more questions. Is it logs checking is so true while working with Hadoop ecosystem? Because Hadoop can handle any type of data. It's not just about the log. It's not just about any specific thing. Hadoop is like a mainstream today that you can even do any type of work with Hadoop. So wait for 3-4 more sessions. There we'll discuss. There we'll see that even we are going to solve real life problems also with Hadoop. So like you can even process the videos, you can process images, you can process your XML sales data. You can, whatever is your requirement, you can really solve with that. Like retails data that we are going to handle. We are going to handle this Twitter's data. We are going to handle XML data, that is again invoices. We are going to handle normal your say totally unstructured data that is in front of your screen. We are going to handle a number of different data types like weather data, like Stack Overflow data, this type of. So it is now a general purpose processing system. I got a bit lengthy question. Okay, you shared an example of system going down for Hadoop will exclude the node from the cluster and will redirect the request to the second copy of the block in different node. Now since for that block there are only 2 copies of the cluster, will it also create the third copy in different node? A good question, Karanjit. I would say really a good question, guys. The question is let me take you to that slide also. By the way, we will discuss this in great details tomorrow, but I think if you have asked this, yes, at any point of time if this system is down, at any point of time if this system is down, now only 2 copies of block 1 is available. Only 2 copies of block 1 is available. Guys, look at it, just 2 copies of block 1 is available now. That is, it's not my required case. I want 3 copies at least. So yes, your master will come to know, and just by running some command, just by running the command, you can balance your cluster. There is a balancing facility is also available that will create. You don't need to even do anything. Just run one command and another copy. Everything will be done by Hadoop. One copy will be created like this. One copy will be created here. A good question. Yes, this feature is by default available in Hadoop. It can handle this, and we can create multiple copies. We can replicate. We can create another lost copy. By the way, this thing we will discuss how exactly this is done, or what will happen. Suppose this machine again come back. I have already 3 copies now. When I have created another copy, when I have created, when I have increased the replication factor, when I have balanced my cluster, I got 3 copies. Now suddenly after say 2 hours, this machine is back. Now I am having 4 copies. Think about it. Tomorrow I'll answer this in the HDFS section. Okay, let me take. Are you going to implement a sample data and multi-node cluster? Yes, we are going to have a multi-node cluster, and there we are going to process our data also. Don't worry. Great, Hadoop does everything. Correct, Hadoop does everything. Okay, a good question. Now guys, all of you, understand this. since I'm having 3 copies available, okay, let's proceed ahead in the map reduce. Now, since I'm having 3 copies available, let me write block 1 directly here and at one more place. Suppose V1 is available here as well as here. Since I am having 3 copies available, so the processing will be done. The question is, will the processing done on all the copies or just one copy? All of you guys answer this question. Will the processing be done on all the machines? Will the processing be done on all the machines, on all the slaves, or just one slave? Will all 3 copy be processed or just one copy be processed? Apart from just one, I think all the answers are correct. Correct, guys. I'm waiting for a few more answers. Correct. Perfect. Just one copy will be processed. Just one copy will be processed. Just tell me, when I'm having all 3 copies are up and running, what is the requirement to waste my processing power? If I process 3 copies, it means instead of, suppose my MapReduce job is taking 30 minutes to process 100 terabytes of data. If I process 3 copies, it will take 90 minutes because I'm processing 300 terabytes of data. Getting my point? So just one copy will be processed. Now, at any point of time, if slave failed, then another copy will come into action. My replication is just like a backup. It's just like a backup so that it will help to fight against the failure. All of you guys, is this clear? Important point, a good point. Okay, let me take another question. MapReduce moves algorithm to nodes, but the result set has to get represented to user back as per his requirement. Does this not involve data mode? A good question. I would say hold for some time. It would be too early to answer. I'll be needing almost 3 hours to show you exact implementation of MapReduce, from end to end working of MapReduce, how exactly my data is processed, how exactly it is saving lots of data movement. Just I think on next Monday, we will be having MapReduce. We'll discuss it there. Okay. Let's proceed ahead. Okay, let me take one more question before that. Will all 3 blocks are run same time? What do you mean by blocks run? Okay, I think you are asking the same question. Will all 3 blocks be processed at same time? No, as I told you, just one block will be processed at any point of time. It will not process three blocks. Otherwise, it will be wastage of processing power. That is pretty important for us. Processing power, that is your CPUs, that is pretty important. That is pretty important thing. Now you will ask me, what is the requirement of 3 copies? Oh, even I got a question. 3 copies, isn't it wastage of space? Yes, if you ask me, is it a wastage of space? I would say it's not a waste. It's an investment. So okay, let's take it other way. Hard disk spaces are very cheap nowadays. With creation of extra copies. If you are getting the features, if you are getting the characteristics like fault tolerance, high availability, scalability, all such features, if you are getting with this, industry is very happy to spend extra in hard disk. Pretty much happy. And guys, at this time you are looking that its data space is wastage, but because it is at application, why you can see the space is getting waste? Because it is at the application layer, where you can see. But if you recall, RAID system, redundant array of inexpensive disk, in all the systems, whether that is Oracle, whether that is DB2, usually we create multiple copies of data. There also we have the data backup available. Okay, let me take another question. At any point of first slave is failed, another slave is start processing from starting or failed position? Good question, but another slave that is running its own work, that is independent what the slave one is doing. Okay, at any point of time if slave one fails, another slave will start from scratch, but it doesn't mean that your work is a start from scratch. Suppose you are having hundreds machines working together, and here I am having block B1, B10, B20, B30, B40, B41, 42, 40. Suppose I am having 50 blocks available here. These 50 blocks will be processed in parallel over all the machines in the cluster. You know, out of your 5,000 blocks, just this machine fails, so 50 blocks need to be processed again. It doesn't mean that this machine is alone going to process all those 50 blocks. No, block B1 is here, but block B10 might be here. So block B10, this work will be assigned to this slave, and in this manner all the blocks that were available here, it is available at some other place. Your master is very intelligent in distributing the work as much as possible, so it will assign that work to another slaves, complete slaves. So the rest 99 slaves will be working to repeat that work, but that work will be from the scratch, but not overall job. How the block is chosen to process? Good question. How the block is chosen to process rather than this copy, rather than this copy? Why this copy? There are certain factors, there are certain criteria, but again I would say it would be too early. Wait for some time. I would say just one thing, main point here is the current load on the system. Whether that particular system is busy or not. Rest few other criteria we will discuss with time. Do we select the block for processing or MapReduce will pick? Harsha, good question, but there is no control over the block that is provided for the users. That is, user can't control blocks. That is, user cannot really specify that I want to process this particular block. Block related every decision will be taken care by a framework. MapReduce itself will take care of everything. You just need to give your data. MapReduce itself will split and create the blocks. You just give your algorithm, MapReduce itself will copy the algorithm to all the machines and process the blocks. So I think I have answered all the questions. Is this clear, guys? All of you? The questions, and even I recommend to all of you guys to take the interest in others' question also, because not today, tomorrow you'll get the same question. Is it possible to process selective blocks from a node? No, Vishal, it's not possible. As I told you, block level operations are not allowed. You can't really do the selective block processing. You can't really handle, that is out of your control. That is taken care by the framework. Okay, now guys, let's proceed ahead, and remaining question we will take towards the end of the session. Okay, so after Hadoop daemon architecture, now the characteristics of Hadoop. First we have discussed. Now second point, distributed processing. Guys, data is processed distributedly. Data is processed parallelly on the cluster of nodes in distributed manner, what we have already seen by the animation. Fault tolerance, failure of nodes, even failure of task, failure of network, failure of any machine, any hardware, any resources is recovered automatically by the framework. Your framework is self-healing. The framework is self-healing. Framework automatically take care of any failure. Okay, let's proceed ahead. Reliability. Guys, Data is reliably stored on the cluster of machines. Data is reliably stored on the cluster of machines despite of machine failure. Suppose your machine failed, suppose hard disk crashed, suppose there is some other issue in the network or any other XYZ issue. There won't be any issue of the data corruption. Your data is stored reliably. You will never lose a single byte of information. You will never lose a single byte of information. Data is always available in your cluster. High availability, that is your data is highly available to the end user. Even say for example at any point of machine, if a machine is failed, no issues. Your data won't, your user won't get an error that the data is currently unavailable. Data will always be highly available and accessible for the processing as well as for the reading. Scalability, yes, now this is again very important thing. There are, by the way, two types of scalability is there. One is vertical scalability, that is we can add new hardware on the node. New hardware can be added on the node, that is called vertical scalability. Guys, we know vertical scale, for the vertical scalability we need to make the machines down. Now if you recall Oracle or any other system, there is just one type of scalability is available, that is vertical. But that is also not really feasible because you need to make your system down and you can't really add more processors. That's really not feasible. Now that's why Hadoop has come up with another type of scalability, that is called horizontal scalability. Again guys, you can note down this feature as a 2-star mark line. Horizontal scalability, that is new nodes can be added on the fly. You can add new nodes in your cluster on the fly without any downtime. Today your work was done pretty much smoothly, pretty much fastly, at optimum speed on 50 node cluster. But tomorrow with time, when the requirement increases, when the data volume increases, at that time you can add more machines. Now guys, adding more machine will give you both, will give you storage capacity as well as processing capacity. Your storage capacity as well as processing capacity will increase. Both these things will increase parallelly. Okay, let's proceed ahead. Another very important reason behind the popularity, that is economic. Hadoop is pretty much economic. That is, it runs on the cluster of commodity hardware. Guys, I have seen the hardware of like they are really a monster hardware. Really monstrous hardwares are people were deploying to run to support their warehouses. The hardware, the biggest hardware, if I recall, that was of 500 gig RAM, 128 core processors. That's really very monstrous machine, a specialized machine. Now 500 gigs RAM. Now guys, if I purchase 100 machines whose configuration if I add will be having 500 gigs machine, 500 gigs RAM. These 100 machines will be 20 to 25 times cheaper than that single machine. Just imagine the cost of that single monstrous machine. So guys, that these specialized hardware that is required for legacy systems were very costly. On the other hand, Hadoop is pretty much economic. It can run on cluster of commodity hardware even in the production as well. Hadoop is very easy to use. Okay, it's again another reason why the developer community has accepted Hadoop. Guys, we do not need to deal with distributed computing. We do not need to deal with distributed processing, distributed storage. We do not need to deal with fault tolerance. We do not need to deal with data split and stored distributedly. We do not need to deal with data high availability. We do not need to deal with data reliability. Rather than that, framework will take care of all the things. What user need to do? User just need to give his data. User just need to give his algorithm. Rest everything will be done by Hadoop. Everything will be taken care by Hadoop. Data locality. So guys, as I told you earlier also, data locality, that is a very important feature, a very nice way, that is move computation. Rather than moving the data, move computation close to the data. You are moving algorithms, you are moving your code to the data, and your code will go there and it will run, because movement of petabytes of data, terabytes of data over the network, not really feasible, not acceptable. Otherwise, your speed of processing will be totally dependent on the network speed. So guys, that's why data movement is prohibited in data world, not even big data world, normal data center data world, it's not accepted. Okay, after discussing the characteristics, let's talk about few assumptions. When Hadoop is developed, there are few assumptions with which Hadoop is developed. It is written with large cluster. It is written with large cluster of computers in mind and is built around the following assumptions. There should be large clusters like 100, 500, 1000, 5000, 10,000 nodes cluster. Hardware may fail. First assumption, there are chances that hardware may fail. No issues. Your system, your framework is self-healing. It will automatically take care of every failure. So guys, as we are using commodity hardware, your hardware can fail. Processing will be run in batches. So guys, there is an emphasis on high throughput as opposed to low latency. Like say for example, you are having 1 petabyte of data. You can develop MapReduce job and you can put a batch. You can submit a batch and that will run and that will process the data. Applications that run on HDFS have large data sets. A typical file in HDFS is in the range of GBs to TBs. Hadoop is pretty much optimized, pretty much fast for large volumes of data. It's developed for large big data only. Applications need to have a write once and read many access model. That is actually happen in the data warehousing industry. That is, you get the facts, you get the data, you get the logs, you get all your data sets, you write your data in your storage system, and then again and again you will process that based on the requirement. That is, again and again you will read and process that. Moving computation is cheaper. Moving computation is pretty much cheap than moving data. Okay, that's the few assumptions of Hadoop. Now let's talk about few design principles of Hadoop. As discussed earlier also, system shall manage and heal itself automatically and transparently route around the failures. No issues, machines are getting failed, then also Hadoop is there to help you to take care everything. Speculatively execute redundant tasks if certain nodes are detected to be slow. Now guys, Hadoop handles the issue of slowness also. If say for example, if few machines are slow, no issues, Hadoop will take care. Hadoop will handle the slowness also. This speculative execution we'll discuss in great details in MapReduce. You can note down this point for later discussion. Even in advanced MapReduce section, not even in basic. Performance shall scale linearly. That is, proportional change in the capacity with the resource change. That is, if I am adding more machines, the performance will also scale. That is, it will improve quite linearly. So guys, that is even you can really understand that. Suppose you are processing 100 terabytes of data on 10 node cluster, and suppose it is taking 2 hours. With double the number of machines with 20 node cluster, the processing time will be half, that is 1 hour. So if I make the number of machines as double, then processing time will be half. Compute should move to data that is lower latency, that is, and lower bandwidth requirement. Simple, core, modular and extensible. Hadoop design is pretty much simple. It's modular and it's extensible. Okay, let's proceed ahead. These are the Hadoop flavors. Meanwhile guys, you have a look at Hadoop flavors. You take a look at Hadoop flavors. Let me take a few more questions. How Hadoop reads the images? Which we can read any type of data, whether that is image, whether that is any type of data. You can just like on the normal file system on your Windows machine, how you create a directory and store the data, similar to that you can store in HDFS. Now how Hadoop can process it? You can use third-party libraries also, as with Hadoop there is no libraries shipped. There is no libraries really shipped with for the processing of video. You can even integrate your third-party libraries also for the video processing. That's again a really nice way. Even people are using processing of the normal documents, PDFs, images, as I told you yesterday about the videos that are getting processed. Let me take another question. Interviewer asked me how much big data I have dealt with. So that is the size of data that you have dealt with. So it based on your what you have worked. So like if you have handled petabytes of data, then your interviewer will be very happy. Okay. Shrikant has asked, Oracle databases move to Hadoop. Yes, you can move your data from Oracle, or you can move your data from any of the location. You can move your data. There is a specific sub-project available. I'll show you that also, how to move your data from the Oracle or from any other system, any XYZ system. What is the factor to detect slow? Nagaraj, wait for some time. This regarding the slowness of any machine, as I have pointed at that point of time only, this is an advanced map reduce feature that we will see after almost 15 hours, 14 hours, almost 14 hours. So that is about, that is again a very nice feature that Hadoop is having. When we'll discuss that, frankly speaking, you'll say, wow, Hadoop is really very intelligent. It is taking care of each and everything. Okay. Srinivas is asking which one is popular. Okay, regarding the flavors, okay, we'll discuss about the flavors, which one is popular. Don't worry, we have not seen this slide. We didn't discuss this slide. Scope of performance testing in Hadoop, as we have many servers and deal with the petabytes data. Harsha, the scope of performance testing is really very high. Actually, we are having multiple machines. Actually, we are having petabytes of data, and certain parameters changes, certain changes in configuration can change your performance like anything. That's why performance testing, performance tuning, all such type of activity is pretty crucial in Hadoop. This type of work, that is this testing, is very important. And frankly speaking, whenever this is, by the way, a role of admin, not a tester. This is a role of admin, that he test the performance and he tune the Hadoop cluster to the best possible way. So if I give you an example, when we were working with the leading telecom client that is from US, what exactly was the issue? They are having a big cluster. Their 3 petabyte of data processing was taking around 10 hours because their cluster was not really optimized. 10 hours, 3 petabytes of data. We were thinking, no, this is really huge. So guys, just with the changes, with the performance tuning, with the performance testing and tuning, we have reduced this 10 hours time to 1 hour in Hadoop. That is even also possible. So Harsha, yes, a good point that you have raised. There is a very good scope for this, but this is a responsibility of Hadoop admin. Okay, let me take this particular slide now. That is Hadoop flavors, guys. Apache, the very first flavor, Apache Hadoop, that is the vanilla flavor, that is the base flavor where the actual code resides. Your actual code resides in Apache repositories. It is the vanilla flavor, it is the base flavor. Apart from that, we have Cloudera, we have Hortonworks, we have MapR, IBM, Pivotal. Now you'll ask me which is the most popular. Cloudera Hadoop is the most popular in the industry, and after that Hortonworks comes. Hortonworks is the 100% open source, that is other components are also open source. With Cloudera, few components are not open source, like Impala solution of Cloudera is not open source, but yeah, it's freeware. Lots of things are free available there, but Cloudera, since an early entrant, It's the most popular. MapR's HDFS, guys, again a very important point. MapR's HDFS is 100 times faster than all others HDFS. IBM is also having its own version, that is Big Insights. Its name is Big Insights. Pivotal is having its own version, that is Pivotal is from EMC. Pivotal is from EMC, that is also having its own version, that's Pivotal Hadoop. So guys, in the industry, maximum people are using Cloudera. Now during our training session also we will use Cloudera. Max developers are working on Cloudera. Yes, maximum developers as well as maximum industries are using Cloudera, that is deployed as a production on Cloudera. And by the way guys, frankly speaking, the base flavor is Apache. That is all the codes that is pretty much same. Like Cloudera is also copying from Apache. Cloudera is applying few patches on the top of that, changing, bundling according to its own way and selling it. Hortonworks 100% Apache. MapR copying from Apache, bundling its own name and selling it. MapR 1 is proprietary. IBM 1 is also proprietary. Pivotal again proprietary. They are copying it and they are selling it. Apart from that guys, from the Amazon, that is a base version available. Dell has discontinued DataStax. They are having the just minor versions that are available, but these are the major versions that are available. Okay, let me take a relevant question just now. How Cloudera is better than Azure? Azure is not a Hadoop. Azure is not a Hadoop. Azure is a cloud. Azure is a cloud and Cloudera is a version of Hadoop, flavor of Hadoop. Shubham, these are both are totally different things. Okay. Okay, let me take few more questions right away. Okay, we'll take it just after the last slide. I think just few more slides are remaining guys. Hadoop ecosystem, an interesting slide. Hadoop ecosystem. So guys, after this, just this is the last slide by the way. Hadoop ecosystem, the last slide. We have discussed HDFS, that is the storage layer. HDFS is the storage layer of Hadoop. HDFS is the storage layer of Hadoop. HDFS guys is the storage layer of Hadoop. Above HDFS we have a layer called YARN, that is yet another resource negotiator, that is resource management layer that will manage the resources of the complete cluster. Above that we have a MapReduce. Above that we have a MapReduce, that is the processing layer. Hbase is a NoSQL database. Hbase is a NoSQL database. So guys, we'll discuss about Hbase also, how it is different from SQL databases or how much volumes it can really handle. We'll discuss that in great detail. Now guys, interesting thing for all of you guys, on the top of MapReduce we are having another component, interesting component, that is called Hive. So guys, Hive support SQL queries. You can submit SQL queries in Hive and Hive will convert that SQL query into MapReduce. So Hadoop ecosystem is taking care of all the people who loves, if you love Java you should concentrate on MapReduce. If you love NoSQL you should concentrate on Hbase. If you love SQL you can concentrate on Hive. Using Hive you can use Hadoop. For the script lovers, there is a component called Pig. You can submit any script here. You can submit Pig script and Pig will convert that script into MapReduce job. Pig will convert that script into MapReduce job. For the data collection we have Sqoop and Flume. Sqoop can help you to collect the data from any SQL, from any RDBMS. Sqoop is abbreviation from SQL to Hadoop and vice versa. That's why the name is Sqoop. So guys, you can collect data from Oracle, MySQL, DB2, anything. By the way, we'll be having practicals also of Sqoop and everything. Flume. Flume is a general purpose data collection system which is used with Hadoop and without Hadoop as well. You can collect the data in real time, in batch mode, based on size, based on the time. Flume is pretty popular. Flume is really very interesting, very important component of Hadoop ecosystem. And for the workflow, we have Oozie. Oozie is for the workflow manager. We can create our complete workflow using the Oozie. So guys, this is the complete Hadoop ecosystem. This is the complete Hadoop family. So guys, there is a component for each and every field. Like for the analyst, for the SQL lovers, you can use Hive. For the scripts persons, they can use Pig. Mostly Hadoop developers, architects will concentrate on MapReduce. By the way, architects needs to concentrate on each and everything. Developer will concentrate on MapReduce. Admins will concentrate on deployment, management, monitoring. ETLs guys can concentrate on Flume, Sqoop, as well as MapReduce, and ETL also for Oozie. Okay, so guys, that's it. Let me summarize today's session. What we have seen today, we have discussed Hadoop introduction. Then after that, the basic architecture of Hadoop. A question, anybody, if you ask why Hadoop, so that also we have discussed. Then two components of Hadoop, that is HDFS and MapReduce. Then Hadoop's daemon architecture. Then we have discussed how Hadoop works, end-to-end working of Hadoop, its characteristics, design principles and assumptions. Then we discussed about the Hadoop flavors. Then we discussed about Hadoop ecosystem. So guys, that's it from my end. Now if anybody is having any questions, any doubts, the platform is now open. Okay, one question. Nagaraj has asked how to identify the particular issue is because of code or infrastructure. You will come to know about this with some practice. That in the sessions we will be having the actual practicals also, with the help of which you will come to know exactly where is the issue. You will come to know about each and everything. Even we are going to, frankly speaking guys, during our advanced session we are going to customize, as I told you earlier, that if anything doesn't work, no issues, customize. So later point of time we will customize the things also, like the way Hadoop reads the data. Don't worry, you don't like it, we will customize that also. Almost all the components of Hadoop is customizable, and we are going to go till the export level, where we are going to discuss about the customization of even complete end-to-end MapReduce flow. Complete end-to-end MapReduce flow. That's really you're gonna enjoy, guys. Okay, let me take another question. Is the Hortonworks fully open source, or some of these are open? Trilokesh, Hortonworks is also fully open source. Hortonworks, the complete components are fully open source, and the same things are available from the Apache as well. Okay, let me take another question. We have practical sessions also. Yes, Shrikant, there are many practical sessions. Actually, why initially I have included theory sessions, so that your foundation should be clear, your foundation should be strong. Then just after two more theory session, then we'll be having back-to-back practical sessions. So guys, from the next Monday we will be having practical session. Karanjit, how will we practice MapReduce? So Karanjit, we will going to practice MapReduce using we are going to set up a virtual machine on all the candidates, and I'll show all the practicals on that virtual machine. We are going to practice MapReduce using the virtual machine, using the Linux machine. Okay. Okay, Krishna is asking, in this course are you covering all the components of Hadoop ecosystem in detail? Yes, Krishna, we will going to cover the components up to certain limits. Like if I give you the example of this Hbase. So Hbase training itself is of 25 hours. That's why we will going to discuss Hbase up to certain limit. Rest, Hive, Pig, Flume, Sqoop, all these components are pretty simple. We will discuss this also in great details. So surely our focus is we are going to cover HDFS and MapReduce to the expert level, to the level of customization, but we will going to surely cover Hive, Pig, Flume, Sqoop to the great details. Surely means you will discuss each and every concept of that also. What are the benefits of Cloudera? Trilokesh, Cloudera is a distribution of Apache Hadoop, and all the features that Cloudera is providing, the same feature is provided by even Hortonworks. That is same feature is provided by Pivotal also. They are just like competitors, and Cloudera is an early entrant. Cloudera is a little more reliable, and being a early entrant, it is in the major position. So even if you learn Cloudera, you can work on Pivotal, you can work on Mapr, you can work on anyone. Krishna is saying thanks a lot, Anish. It was great seminar with clearing every concept. Thank you so much, Krishna. Okay. Shellers require how much RAM size require Cloudera? Actually, you should give 2 GB RAM to your these systems, to your virtual machine that will be needing for Linux. So it is recommended to have 4 GB RAM in your system, but I have seen people are working on 2 GB, 3 GB RAM also. But I'll recommend you for really 4 GB RAM in your system, out of which 2 GB you can give to your virtual machine, to your Cloudera Hortonworks. Mohit is saying I have attended. Okay, that's great. Mohit is saying I have attended many seminars earlier, but this is one of the best. Thank you so much, Mohit. Samik is saying thanks a lot for a great session. Thank you so much, Samik. Yes, Rama, you can ping. Okay, what is the hardware specification for Hbase installation? Rama, are you asking for the production installation or for your learning for our sessions? Actually, for the production, we will be having discussion about what should be the hardware, what should be all such things. And regarding the learnings, just a 2 GB system would be sufficient for our learning, for our end-to-end working purpose. 2 GB systems will be more than sufficient. And by the way, guys, we are going to use our cloud also. So there we are going to set up Hadoop on the cluster, and there also will use the same. But for all your working, I think 2 GB RAM would be more than sufficient. And out of your, if you're having 4-core processor, 2-core you can give to your virtual machine, that is to Cloudera. And for the disk also you can give 20 GB, 50 GB, 80 GB, whatever you are having. Accordingly you can do your practicals. Okay, Rajat is saying really informative. Thank you. Thank you so much, Rajat. Can I do practical on VMware with install Linux on it? Yes, because we are going to follow the same. We are going to do our practicals on VMware only. We'll install Linux inside VMware. Trilokesh is saying, is there any security issue to use Flume? Because by using Flume, we can get those data from Twitter or any others. Trilokesh, there is no really security issue. Means Flume is pretty a reliable solution. We can get the data from Twitter, but because Twitter is allowing us to get the data. Twitter is allowing us to get the data from them. That's why we can get the data using Twitter. Regarding the security, there is nothing security issue using the Flume. Harsh saying all these HDFS, MapReduce, Hive, etc. will be installed in same machine. Yes, all this can be installed in same machine for your learning. For your learning. But in actually, when we'll see the practical, actually when we'll see a cluster setup, there we will use Amazon Cloud EC2, and there we are going to use 3 machines. One will be master, 2 will be slave, and all such things we will see. Okay, where exactly we can install. So in the production, this will be on multiple machines, but for your learning, your testing, we can deploy this on single machine. So in actually, if I give you the configuration of our development systems, our development environment, there also we are getting just one machine. On one machine, the complete Hadoop is installed. Hadoop, Hbase, MapReduce, Hive, Pig, Oozie, everything is installed on one machine for the development environment, and in the production these are deployed on multiple machines. For Hbase, 2 GB RAM. Rama, I understand for Hbase 2 GB RAM is little less for all your big data processing of huge data, but for your learning I think you can use that, but I'm saying minimum 2 GB, maximum you can have anything if based on the practical, based on the things whatever you want to try, but yes, 2 GB is minimum requirement. And are we going to use Amazon? Yes, we are going to use Amazon also. Is that a free? Amazon is not free, Rama. Amazon is a paid thing, but it's a very nice payment model that is pay per usage. That is, if you are using a cluster for like 1 hour, if you are using like a 5-node cluster 1 hour, you just need to pay for 1 hour. That is 1 hour normal machine charges are like 3-4 rupees. So it's very cheap. It's really very cheap, and we are going to use, by the way, in our sessions also AWS, and even I recommend all of you to create your own account also. Account creation is pretty much free. Okay, Trilokesh is asking then how we can handle our security of data. If any user use Flume, they can get data. It is open source. So can we modify this? Trilokesh, it doesn't mean that any user can take your data. It's open source, but any users can't take your data. There is a specific settings that configurations are available. Yes, we are going to do all such settings also. Like if you are collecting the data, your data nobody else can collect. There you will be having your own agents will be sitting, your own clients will be sitting, that only will send data to you, and that data will be collected by only by you. Nobody else can really collect your data using the Flume. Don't worry, it's pretty much secure. Which flavor to begin with for a start? Cloudera, Karanjit, Cloudera, the same flavor we are going to use in our sessions also. So guys, as same as yesterday, today also you will get the recording session of link of this recording of this session. By the way, I hope all of you guys have received the recording, as I've got few ping that some guys didn't receive. If I can get a just ping from your side, guys, did you get the recordings, all of you? Or you can mail, you can mail us on the info@data-flair.com. Okay, so guys, I have pinged you the email ID. You must get an email ID. You will receive the link. All right, guys, that's it for the day. Thank you so much. Tomorrow, again, our session will start at 9:30, sharp 9:30 p.m. IST. All right, thank you so much, guys. Bye bye.